All right, we're going to do one problem, 614. Okay, and on Friday, we're going to change this. There's a typo here. That should say on Monday. Your biology class starts a bacteria culture in a dish. Okay, you start with 2,000 bacteria in the culture. By Wednesday, there's 4,500 bacteria. According to your biology text, the number of bacteria in the culture should increase exponentially over time. Okay. Sorry, we're on page 168 in your notes packet if you're following along. Okay. So Monday, you start with 2,000. By Wednesday, 2 days later, you have 4,500. So it looks like a little more than doubles. Okay. So you might understand populations in general will grow exponentially. Sometimes they have a doubling time. So you might say the population of rabbits doubles every 10 days or something like that. Or you might have the amount of money in an account doubles every 12 years. Okay, you might, those are things that grow exponentially. That's property of exponential functions. Okay, so by what factor did the number of bacteria increase in the 2 days from Monday to Wednesday? So on Monday you had 2,000, and on Wednesday you had 4,500. So what did we multiply? Times what? Okay, to find that, you do 4,500 divided by 2,000, which is going to be 9/4. So that's a little more than 2. 8/4 would be doubling. So a little more than doubles every 2 days. Okay, use this predict the next Friday and Sunday. So you've got Monday, you've got 2,000. Okay, you multiply by 9/4. So Wednesday, you have 4,500. Okay, now by Friday, you're going to multiply by 2/4 again. So times, I'm sorry, by 9/4 again. And that's going to give you 10,125. Okay, 2 days later, by Sunday, multiply by 9/4 again. And you're going to have 10,125 times 9/4. And you get 22,781.25. Okay, so that was just kind of neat to see. We're actually now going to come up with an actual particular equation. Find the particular equation of the number of bacteria is a number of days that have elapsed since, I'm going to say since Monday, when we originally had 2,000, when the culture was started. Okay, so X is number of days after or since Monday. And Y is the number of bacteria in the dish. Okay, so we've got a couple ordered pairs. We're going to write our ordered pairs. On 0 days after Monday, on Monday, we have 2,000. And then our next ordered pair is 2 days later. So when X is 2, 2 days since Monday, so that's Wednesday, we have 4,500. Okay. Now, you know how for an equation of a line, you've got Y equals mx plus b. Equation, general form for an exponential equation is Y equals A times B to the X. Okay, so we're going to plug in our first ordered pair. It's always going to be easiest to plug in one where you can have an X value of 0. And you can see why. When you plug in 0 as our exponent, anything to the 0 just becomes a 1. Okay, so if we plug in this ordered pair, the Y is 2,000 equals A times B to the 0. B to the 0 is 1, so 2,000 equals A. So now we've got Y equals 2,000 B to the X. Okay, now let's plug in the second ordered pair. Okay, I'll go up here. So 4,500 equals 2,000 times B to the second. Okay, so divide by 2,000, we get 9/4 equals B squared. Square root Okay, well, that works out nicely. 3/2 equals b. So our equation is y equals 2,000 times b, which is 3/2, to the x. Okay, so now we're going to graph on the expire the first 9 days from the first, okay, that's going to be Monday, to the second, so that would be the second Wednesday, right? 9 days later. Sketch the result. Converting your equation is correct by tracing to the 2 given days. Okay, so let's type this in. Let's just make a new graph. Y equals 2,000 times just 1.5 to the x. Okay, remember on day 0 we had 2,000, so we have to fix our window. Menu, window settings. So let's go, we want the first 9 days. So let's go like -2 to 10. And our y is going to go from, I don't know, let's do, our y's are going to get really big. Remember by Sunday we were at 22,000. So let's go -20,000 to +200,000. Is that going to be enough? Okay, that's okay. We could maybe that looks about fine. So let's trace for the first 2 days. Remember how to trace. Menu 5 for trace, 1 for window trace. You type in a 0, hit enter, 0 2,000. Let's type in 2, hit enter, 4,500. Let's type in 4 just to double check our other points, 1025. And then 6, because Sunday was 6 days after the original Monday. Hit enter, and it looks like that's right. So now that we have our equation, we could figure out any day. We could now say how many do we have on that first Tuesday, so 1 day after. So we went to 3,000. Okay, so we could plot this, sketch the result. We'll just do a rough sketch. It looked something like this. We know that this was the point, 0, 2,000. We can plug in a point, let's say 6, 1, 2, 3, 4, 5, 6. So this was 6, 22,781. Okay. Number of days since Monday. Number bacteria. Okay. Predict the number of bacteria Thursday this week. Which to use interpolation or we're actually just going to use the actual equation. Okay, so Thursday of this week. So that was Monday. Day 0 was Monday, and I think these days are messed up. So that's going to be Monday, Tuesday, Wednesday, Thursday. If I want to find the actual Thursday of the second week, or Thursday of the first week, let's say that's day 3. Okay, I know the days got a little messed up. So if we want day 3, you're just going to type in a 3, hit enter, 6750. 6750. Okay. If you wanted the following Thursday, well, that would be 7 days later. Day 10, just for fun, let's do that. Day 10. Okay, 115,330. 115,330.078. Predict the day on which the number of bacteria reaches 40,000. Okay, so what we have to do here is now we have to type in y equals 40,000. And we're going to find that intersection. Okay, so menu, we could do analyze graph, find your intersection, hit enter, go over here, hit enter. It's tough to see that, but I think we can see it. So that looks like it's day 7.388. So your x would equal 7.388. So that looks like somewhere between days 7 and 8. Between days 7 and 8. So that's 7 days after the original Monday. So someday between the second Monday and Tuesday. Okay. And I think we already talked about this dilation factor. I think that's just the, what are we talking about there? The by what factor did it increase every? Oh, okay, the dilation factor. I see what it's saying. So that's the 3/2. So your 3/2, the b in the equation is 3/2. Okay. So that basically means every day, each day, the number of bacteria is multiplied by 1.5. Is multiplied by 1.5, which means if you had a certain amount, you multiply by 1.5, it's growing by 50% each day. Okay, so it grows by 50% each day. All right, well, that's it for now. There is another one that you can try. The population problem on the next page. You can try follow exactly the steps we did for this one. And then there's a couple problems in the book. Thank you again.